welcome back to another video. So today we're going to be solving the LeetCode question number 22, generate parentheses. Okay, so I think this is a really interesting question, and I'm going to try to explain it in such a way that if you kind of understand how this question works, you should be able to solve any question of this type. So just stick around for the explanation, and especially if you don't know how to solve it, I think it'll be really helpful. Cool. So over here, given n pairs of parentheses, write a function to generate all combinations of well-formed parentheses. So essentially, what does well-formed means? That means that it has to be valid, right? So what that means is you can't have 4 opening parentheses and 2 closing parentheses. So you have that. And also the other thing is, let's say you have open, open, and then you have close, close, close. That cannot be the case, right? So if you have 3 open, only after that you can have 3 closed parentheses, right? So they have to be matching essentially. So given a number n, right? So let's say have 3 pairs of parentheses, so a total of 6. So 3 open, 3 closed. Show all the combinations. Okay. So the question itself makes sense. Okay, sorry. So let's just look. So let's just try to understand how we can solve this. Okay, so let's start off with a very straightforward example in the beginning. So let's say we have n is equal to 2. So this means we have 2 pairs. So the total length of it is actually going to be 4. Okay? So let's actually start off with a very basic scenario. At any spot, we can have two options essentially, right? We can either have a opening parentheses or we could have a closed parentheses, right? Open or closed, open or closed, open or closed. So now let's actually come back to something else, right? So let's just look at this as it is. So let's say given at each space, I have the option of open or closed. Let's try to come up with all the possibilities. So over here, I use a very basic idea called backtracking, okay? And this is going to be how we solve this question, but we're going to modify it a bit, okay? So what exactly does this mean? Well, what it means is we try every single possible combination. So the way it works is, let's say in the beginning, I have a open parentheses, and the next one is open as well, and so is the next one, and so is the next one. Now this is not valid, but I'm just trying to show you how this would have worked. Okay, so this is going to be one solution. Now I backtrack, so I go back one step. So currently I'm on this. So have I looked at all possibilities? No. So over here I could look at this possibility as well. Okay. So now given these 3 staying as it is, did I look at all possibilities? I have. So now I backtrack one more step, okay? So this is going to go back to the original value, and now this is going to be the closed parentheses, okay? So closed, so now this would be open, and now we backtrack again, and now this would be closed. So essentially, we keep going back one step until we have looked at all the possibilities. And at the ending of this, you essentially come up with every single possibility. But now we have some conditions, right? So if you look at the first case where we had everything as an open bracket, that is not valid, right? So that is a problem, and that is what we are going to fix, okay? So let's start off with some very basic thing. So whatever the first value is, has to be a opening bracket, right? You cannot have a closed bracket without a previous opening bracket, okay? So we can kind of, make this constant. The first is always opening, no matter what the end value is, okay? And what I'm going to do on the side is I'm also just going to draw this as a tree. That should be kind of easier to understand. Cool, so I have this. So now let's move on. So over here, I have 2 options. I could either have a opening bracket or a closed bracket. And in this case, both of them are valid. So one more thing I'm going to do is I'm going to keep track of the number of opening and the number of closed brackets I have. So the number of open in this case is 1. The number of closed is 0. Okay. So let's say I start off with a opening bracket. Okay. So now I have a opening bracket. So this is going to be, so essentially the first one is a opening bracket, and then I have 2 options, which is either a opening bracket or a closed bracket. Okay. So for now, let's just choose the opening bracket. So now I go on to the third kind of block. So over here, what are my options? I can either have open or closed, but I actually cannot have a opening bracket. Now this is one of the conditions, which is, so look at the number of opening brackets, right? Since we have 2 pairs, we can only have a maximum of 2 opening brackets and a maximum of 2 closed brackets. So we already have 2 opening brackets, so that means that we cannot have any more opening brackets. So now the only option we have here is a closed bracket. Okay. So before we had a count of 1 and we added one more opening bracket. So now this became 2 and 0. So now since the number of opening brackets is equal to n, we cannot add any more opening brackets. So now we have to add closed brackets. So right now we add a closed bracket over here. And even for the last one, we add a closed bracket. So now in the tree, this looks like this. We add a closed bracket and we add one more closed bracket. Okay. Now remember, this is given that I chose this to be a opening bracket. Now if I chose that, the other two have to be closed brackets. So essentially over here, we found a path of length 4. So this is going to be one possible solution. Okay. So now we backtrack. Okay. So we've looked at all possibilities with the second spot being a opening bracket. Now let's see what happens if we take it as a closed bracket. So essentially this is the tree that we're going to be following. We're just going to explore this tree and we're going to prune it whenever there is a solution that is not valid. Okay, so let's see what happens right now. So now instead of the opening bracket, I'm going to choose the closed bracket. So what is the count? Well, so okay, this is a closed bracket. And now we have one open, one closed. So what am I going to do over here? Okay, so over here, again, two options, open and closed. Now the question is, can I choose the closed bracket? And the answer is no, because there is not a open bracket prior to this, which is not accounted for. That's it, okay? So right now we have, so let's say I choose a closed bracket. Well, we are not closing anything. All the open brackets previous to it have already been closed. So the other condition we have is we can only add a closed bracket when the number of closed brackets is less than the number of open brackets. Okay? And that way we ensure that there's always an open bracket that has to be closed. So in this case, we cannot add an open bracket. So the only option we have is to have an open bracket. So we cannot have a closed bracket. We can only have the open bracket. So now that is our option, right? So we have to have the open bracket. And now, so the count of open is 2 and the count of closed is 1. So now finally, the number of open brackets is equal to n. So the only option we have is the closed bracket. So that's it. So now the count becomes the same. And we have one more path. So essentially over here, we have looked at all the possibility with n is equal to 2. Okay? And so all the values are going to be all the different paths we have. So look at this over here. So the path we have is open, open, close, close. That's one solution. And the other one is open, close, open, close. That's the other solution. That's it. We have two solutions for n is equal to 2. Okay? So that is basically it. I think so if you understood this so far, you can directly skip to the code. If you did not, I'm going to do another example with n is equal to 3. And what I'm going to do is I'm directly just going to draw the tree. And this should make it completely crystal clear. Okay? So in the beginning, what are my options? So I'm going to keep track of two things. I'm going to also keep track of the open count, comma, the closed count. Okay? So this is how I'm going to write it. So in the beginning, what are my two options? Well, I could either have, so either open or closed. But like I said, you can only have open. Okay? So we start off with a open bracket. Okay? Now, what are my options? I can either have a open or I can have, let's just make it slightly bigger, sorry. So I could either have a open bracket or I could have a closed bracket. Now, if I have the open bracket, the number of open brackets I have are going to be 2. The number of closed brackets are 0. So over here, that would be 1, 0. Now over here, I would have 1 open, 1 closed. Okay, so let's just see how this is going to expand, and it's going to make complete sense after this. Okay, so over here, 1, 0, 2, 0, 1, 1. So let's actually go down this path, or let's do it level by level. Okay, so over here, what are my two options? Well, again, my two options are I can either have a opening bracket. In that case, I would have 3 opening and 0 closed, or I could have a closed bracket. If I have the closed bracket, I would have 2 open brackets and 1 closed bracket. Okay, so now let's expand it furthermore. So let's look at this case. So over here, I already have 3 open brackets, right? As we know by the count. So that means I cannot have any more open brackets. So everything after that is going to be a closed bracket. So right now we have a closed bracket. Now that count becomes 3 comma 1. We have one more closed bracket and one more. So this becomes 3 comma 2 and this becomes 3 comma 3. So this is one path, right? So once the path length becomes 6, we are done because we have 3 pairs. So 3 times 2 is equal to 6. Okay, that's it. So now let's move on, right? So let's look at this over here. So over here, what can I do? So since the number of closed is less than the number of open, I can have a closed bracket. Okay, so I could have a closed bracket. This count would be 2 comma 2. Or I could also have a open bracket. And sorry, this would be closed. My bad. Okay, or I could have a open bracket. And the reason for that is because the number of open brackets is still less than n. So in this case, it would be 3 comma 1 if I add the open bracket. Okay, so let's continue. So now in this case, same thing happens. The number of open brackets are 3. That means I cannot have any more open brackets. Okay, so now this becomes, so now the only thing I can have are closed brackets. So now a closed bracket that becomes 3 comma 2 and one more closed bracket becoming 3 comma 3. So this entire thing over here is another path. This path is another answer. That's it. Okay. So now let's move on to this. Okay. So over here, what can I do? So the number of closed brackets is not less than the number of open brackets. So that means the next one has to be a open bracket. The count becomes 3 comma 2. Now since 3 is equal to n, I cannot have any more open brackets. So I have to have a closed bracket with 3 comma 3. That's it. So we have explored every possible pattern with the second value being a open bracket. Now let's look at what happens when the second value is a closed bracket. So right now, the number of open brackets, the closed brackets is not less than the number of open brackets. So the next one has to be a open bracket. The count becomes 2 comma 1. Now over here, I can either have a open bracket or a closed bracket. Okay, so over here, this becomes 3 comma 1 and this becomes 2 comma 2. Now over here, since I already have 3 open brackets, everything else is a closed bracket. Okay, so that becomes 3 comma 2 and that becomes 3 comma 3. Perfect. Okay, and finally over here I have 2 comma 2. What happens over here? So essentially I need to have a open bracket. So I have an open becomes 3 comma 1, and finally now I have a closed bracket. Sorry, 3 comma 2, and this becomes 3 comma 3. That's it. So now how do I get the final result? The final result is all the paths. Okay, so this entire path is one result. Okay, so that's one result. Now this entire path is another result, right? This entire path is the third result. This entire path is the fourth result. And finally, this entire path is the fifth result. And if you look at the actual thing over here, you have 5 solutions, and these are exactly what you get. So that's it. This is how we're going to solve our question. And hopefully that example really helped out. So what I'm going to do is I'm just going to directly show you what the code of this looks like. Okay. Cool. Just one second. Okay. So essentially, I wrote the code, and I'll just explain it quickly. So the idea is the same thing. Okay. So we're going to keep track of all our results over here. So over here, we're going to have a helper function. So what are the things we're going to keep track of? We're going to have a path. We're going to have the options. Now, what is options? Options are at a given point, what are the possible values I can have? Can I have a opening bracket only? Can I have a closed bracket only? Or can I have both? Okay, so that is going to be essentially it. So in other words, what are we exploring? Now, in the beginning, we're going to have an empty path, and the first value always has to be the opening bracket. So the only option is the opening bracket. Okay. And we're going to keep track of the number of opening brackets and the number of closed brackets, both starting off at 0. Now, if at any point the length of the path is equal to n times 2, then that means that we have reached the ending. And at that point, we're going to add that path to our result. Okay, that's it. So now let's see if that's not the case. So if that's not the case, that means we're still building out our path. So what we do is we look through all the options, okay? And let's say let's say right now we have a option, and in the beginning, the option is just going to be a opening bracket because, like I said, the first one has to be a opening bracket. So what we do is we add that to the path. So current path is equal to path plus the option, and we check what the option is. So if it is a opening bracket, we increase the opening count by 1, and the closed count stays as it is. And if it's a closed bracket, which is over here, the closed count increases by 1 and the opening count stays as it is. So now we got to look at the new options, okay? So now we have the new count, the current count and the current opening count. And now we need to add the options, okay? So if the current opening count, so the number of opening brackets is less than n, then that means we can have another opening bracket. So in that case, we add the opening bracket as one of the options, okay? Now the other condition is if the number of closed brackets is less than the number of opening brackets, then that means we also have to explore, or we can explore, a closed bracket. So we add that to one of the options. So now we have the new count, the new options, the new path, and yeah, that's it, right? So now we call the function recursively, right? So we have the helper, we give it the new path, the new set of options for the given path, the current count, and the current close count, open and close count. So now this is going to keep building out all the valid options, right? So let's say at one point, the number of open and close brackets are the same. Then in that case, we cannot add the closed bracket as an option, right? So we only explore the valid options, okay? And when the path reaches the actual length, which is n times 2, in that case, we append it to our result. So this is basically our solution. So I'm just going to submit this. Cool. So as you can see, our submission was accepted. So yeah, that should be it. Hopefully this did help out, and do let me know if you have any questions. And thanks a lot for watching, guys. Bye-bye.